In this video, we will introduce the base model used in the wind farm application example. Activate the study case base case. Here you can see the network model. The network consists of 6 individual wind turbines, each supplying the 20 kV network via a step-up transformer. At the point of common coupling, there is an external network. And at the wind farm's substation a capacitor bank is connected. Let's take a closer look at the wind farm substation. Right-click on the buzzbar and select Show Detailed Graphic of Substation. On the top left part of the wind farm substation detailed diagram, the PCC is shown, which is part of the distribution network. The separation between the distribution network and the wind farm is indicated by the property line. Here the 4 switch bays of the wind farm substation can be seen, as well as the location of the 2 cable overcurrent protection devices, and the voltage protection device. Let's go back to the overview diagram and look at the wind turbines in more detail. The wind turbines are all identical. They have a nominal apparent power of 2.778 MVA, and a nominal power factor of 0.9. A dynamic model has already been assigned to each of the wind turbines, and this can be accessed via this arrow. On the load flow page, you can see that the active power output is to be defined according to wind speed, using this wind power curve. The wind generators are all controlled by a single station controller, which controls the reactive power output. On the operational limits page, you can see that a capability curve has been applied to the wind turbine model. The station controller can also be accessed here. On the load flow page, we see that the control mode is set to power factor control, and the point in the network at which the power factor is controlled is shown here. The station controller applies a cos phi as a function of P characteristic. When the active power at the controlled node is 7.5 MW or less, the overexcited power factor is set to 1. When the active power at the controlled node is 15 MW or more, the underexcited power factor is set to 0.95. Between these active power set points, the power factor decreases linearly. In the table on the Distribution tab, you can see the wind turbine generators, and the proportion of the total reactive power that each is supposed to supply. As an extension to the existing wind farm, we will introduce a new wind turbine model into the network. First, unfreeze the graphic. Place a point node in the network as shown. We will place the node halfway along the cable. We will now create the new wind turbine, using a suitable template. Select the template fully rated converter WTG 2.5 MW, click once in the diagram, position the template, then click again to connect the generator to the point node. Then finish by pressing Escape. Notice that the generator is already configured with power set points of 2.5 MW and 0 MVAs. A capability curve and a dynamic model have also been assigned by the template. If we now run a load flow on the system, we can see the active and reactive power outputs of the generators. You can see that the new wind turbine is generating 2.5 MW. But 0 MVAs. If you look at the other turbines, you will see that each of those is absorbing 0.76 MVAs. This is because the new turbine is still configured to local control. In order to let the new turbine participate in the reactive power control of the wind farm, we need to add it to the station controller. Right-click on the new turbine and select Add to, and then Station Control. Select the station controller. Take another look at the controller. You can see that the new turbine is at the bottom of the list. Run another load flow. You can see that at the point of common coupling, around 17 megawatts of active power is being fed into the grid. COS-phi is controlled to 0.95 according to the characteristics that we set in the wind farm controller. Notice that the new generator is now absorbing the same reactive power as the other generators. Since we have introduced the new generator, we should update the parameters in the COS-phi as a function of P characteristic. Let us increase the active power to 17.5 megawatts to reflect the new nominal power of the wind farm, and rerun the load flow. You will notice that the active power at the point of common coupling is less than 17.5 megawatts. The power factor is therefore now a little greater than 0.95. In accordance with the updated linear power factor characteristic,